Okay. So I'm recording, just so you know. But reals is everything that we're working with. Okay. And imaginary, we're actually going to cover, I think, here at the first unit. So we're going back to look at what is an imaginary number. You guys remember?
A negative root or whatever.
And there's only one of them. There's only one imaginary number. Square root of -1. That's it. Okay, so we'll talk about that a little bit later as well. And then, of course, irrational, and then rational, integers, and natural. There's actually one set that we never talk about, but when you were younger, in earlier education, they probably talked about whole numbers. Okay, what's the difference between a natural number and a whole number? See, the natural numbers are 1, 2, 3, 4, 5, 6, right? If it is the set of whole numbers, there's one number missing. What is it? 0. 0 is considered a whole number. But we just don't worry about that extra set. Okay, it's just natural, integers, rational. If you want to talk about the whole numbers, it's just going to be integers that aren't negative, non-negative integers. It's the same thing. So those are your number sets. If that helps, great. If it doesn't, I'm sorry. Here we go. 1B. 1B should be a little bit of review. You should have seen this before. Stop me. And also, too, we're going to jump through a couple different categories, from interval notation to distance to prime numbers. So 3 basic topics today. I don't have these as bullet points, so if you like formal notes, go Roman numeral 1 or Roman numeral. I don't really do that. But if you want to, you can. This would be Roman numeral 1 if you want to. And that's types of intervals. Hopefully, your Algebra 2 teacher taught you interval notation. I know if you went to Center, all of our teachers do teach interval notation. And we have really 4 different types. Okay? One of them is called an open interval. So let's say we have a number line, and we have 2 points on that number line. We'll go open circle A to open circle B, and all the numbers in between them. If you want to put numbers in there, we could say, this is 1, this is 2, all numbers between 1 and 2. What does it mean to be open? What does it mean to be an open interval?
I'm rusty right now.
I'm looking at my, what'd you say?
I'm rusty.
I'm looking at my Algebra 2 students going, I know I taught you this. What does it mean when it's open?
It keeps going.
No. Good guess, though. Appreciate the guess. What'd you say? What'd you say? I just sworn I saw you. It doesn't keep going. It actually is going to stop. Does the answer include A, or does the answer include 1? No. No. It does not include endpoints. Okay, so an open interval does not include the endpoints. So it's from A to B. It's from, if we use 1 and 2 as our numbers, it's between 1 and 2. It's not 1, it's not 2. 1.1 would be fine, 1.5 would be fine, but it cannot be 1, it cannot be 2. Yes?
So is it like marking the points on the number line without like actually marking it? It's just saying they're between these two. Like a dot, but since it's a circle, it's not a dot.
Correct. So it's open, meaning it's between them, but it's not including the endpoint. The endpoint's not including my answer. So if I were to say, is 1 the answer to this, you would say no. Okay. Now, what symbols do we use in equality to symbolize this? Yes? Greater than or? Not equal to. Greater than or less than. Okay. Those symbols is what we use to declare an open. Now, even further than that, in interval notation, I'll give you a 50-50 on this one. Is it a parenthesis or a bracket? No, it's a parenthesis. So I would call this interval A comma, B. And it does look a lot like an ordered pair, and we're going to differentiate the context of the problem as to whether it's an interval or is it an ordered pair. If I'm talking about a graph or an XY axis and a point, it's an ordered pair. If I'm talking about a function, it's probably going to be an interval. Okay? So an open interval does not include A or B. Okay? Coming back? Yes? No? Yes? By the way, for those of you who are new to my class, I do have this every person responds thing, so if I ask a question that I want everyone to respond to, here's the numbers, and you can just show me like a 1, 2, 3. If you show me a 1, make sure you show me this finger. You know what I'm talking about. Those of you that want to show me one finger, don't show me that one, show me this one. Okay? Brennan. So 1 means I have no notes, I have no idea, I just woke up, don't bother me. Okay? Don't show me a 1, that's a bad thing. 2, I still need examples, still need guided practice. Number 3 means, you know what, I got this, I'm ready to move on, or do independent practice. Number 4 means, I am ready for the test. You don't have to do anymore, I got this. And number 5 means, I'm ready to teach someone else. Not only do I know this topic well enough, I'm ready to teach somebody else. So when I say something like, you got the open interval, give me a 1, 2, 3, 4, 5. 6, okay, that's awesome.
No, that was a 5 minus 1.
5 minus 1?
Yeah.
So difficult. Okay. All right, and you can do it slow so people don't see it. All right. All right, fantastic. So with an open interval, all it means is A and B are not part of the answer. It's not part of the solution set. Okay. So if I give you an interval, let's say 4, 10. 4, 10. Is 6 a solution? Yes. Is 11 a solution?
No.
10? No. 9.9993.
Yes.
Absolutely. Anything between the two is a solution. Anything the actual numbers aren't. Okay? Now, obviously, if I have an open interval class, what do I also have? I also have a closed interval. Okay? So, closed interval. So I'm going to use that number line again. And we're going to use from A to B. All right, so rather than an open dot, which I use for an open interval, for a closed interval, I'm going to use a closed dot, a filled in dot. And everything in between. And we can put numbers in here again, like let's say 1 and 2. Okay? So, if an open interval does not include the endpoints, what does a closed interval do? It includes the endpoints. Absolutely, 100% includes the endpoints. All right. What inequality symbols do I use for a closed interval, Emma?
So less than or equal to.
Less than or equal to?
Less
Less than or equal to? Greater than or equal to? Exactly correct. Oh, that little line. So that little line is going to mean the endpoint's included. If the little line isn't there, you don't include the endpoint. Okay. What symbol am I going to use for these? Brackets. Just like that. So I would say A, comma, B. And now the endpoints, 1, 2, whatever, or if I give you an example of, let's say 4, 10, now 4 and 10 are part of the solution set. All right, we got open and close. Good with that? Now, I told you there were more than 2. How many did I tell you there were? I think there was 4. Okay, so if there's 4 possibilities, I have 1 is open, 1 is closed. What's the other possibilities? Half open, half closed. Yeah.
Oh, wow.
And it can go either way. So that's the other 2. So we have half open, half and half. So I could have A, B, or I could have A, B. All right, take off your college algebra hats, put on your geometry hats for a second after you write it down. Yes? Yeah, you don't have to tell me. I am recording this, so the video, but you can get notes for somebody else too.
What are you doing right now? Oh, sorry. I forgot.
Yeah. Have fun. Learn lots. Okay, so half open, half closed. These are the other two possibilities. Put on your geometry hat for a second. What object from geometry would be considered a half open, half closed interval? I'm going to tell you what it looks like. Let's say I have a number line, and I go from closed point A to open point B. What do you think, what type of geometry object would relate to that?
I lost my geometry.
Pick it up, put it back on.
I don't know where it is.
Okay, you're going to answer this question because I know you know. Because I know you know this answer. It has an endpoint and it goes in one direction. It's a boy's name.
Oh, a boy's name.
What'd you say?
A boy's name.
No. Yes.
Ray.
Ray. It's Ray. See, I knew you knew Ray. It's coming back quickly. So it's very similar. It's very similar to a ray because it has one endpoint. Now, they could either stop at an open or they could continue forever. They could go on like a ray forever. But a half open, half closed, where one of them is open, the other one is closed, it can go either side. Okay. All right. By the way, let me go back. I'll come back to this one in just a second. Let's go back to the closed one. What geometry symbol is that closely related to? I heard it like 4 times. What'd you say? Line segment. Okay, line segment has 2 endpoints. Okay, very, very good. All right, so we have half open, half closed. We have closed, we have open. Those other things. Okay. Now, these are all what we call, did I talk about this? Okay, types of intervals. These are all called bounded. So if you have notes off to the side, you could write bounded. In other words, they have a boundary. Okay? They go a certain distance and they stop. So they're bounded. They have a boundary. So just like if we have an open, we also have a closed. If I have a bounded, I also have a unbounded. Okay? So let's look at unbounded. So bounded, we have the open, we have the closed, we have half open, half closed. It could go either direction. So the second one is going to be unbounded. So what type of intervals are unbounded?
They just be ones that don't end anywhere.
They don't end. They may end one place, but they're going to go on forever in another direction. So let's look at a couple of examples. First one. I'm going to give you A, which is an endpoint. It includes an endpoint. But then it goes on. What symbol do I use to go on forever? Infinity. Infinity. Is infinity a number?
No.
No, infinity is an idea. It's an idea that goes on forever and ever and ever. Okay. So then, class, here's a deep thought for you. What's bigger, infinity or infinity times infinity? No.
It doesn't exist.
They're equal. They're equal to each other because they both go on forever. Okay.
Okay.
So what's bigger, infinity or infinity minus 1?
That's like 1 versus 1 times 1.
Yes. So what's infinity or infinity minus 1?
They're equal, right?
They're equal because infinity goes on forever. Okay. So A, and then to infinity. Now infinity is unbounded. It's an open and there's no endpoint. There's no endpoint, so it's always a parenthesis. Okay? So remember that. Infinity has no endpoint. Therefore, it's always a parenthesis. Okay? So if I were to sketch a line, this would actually be what my array would be. A, and then it goes on for infinity. A, and then it goes on for A. All right, how would this differ? Number 2. A, comma, infinity. How would that differ? Say it again. It's open. The A is an open part. So you have open circle to infinity. negative infinity to a. Say it again? Yeah, so the infinity is going to the left now, correct? Because this side is always going to be the smaller number. When you look at the interval notation, the left side is always the smaller number. So if I look at your homework, I'm grading through your homework, and I see a number that says something like 4, negative 2. We immediately know that that is wrong. Okay, because the smaller number always has to go to the left. So it would actually be negative 2 to 4. That would be wrong. Okay? So since we're going negative infinity to a, that means it's going this direction. Let's see, I did fill it in. So a then goes to the left. And we have to say it. We have to say it. It goes to infinity and b. Outstanding. Then of course I have negative infinity and open a, which is the same thing, only as an open circle. All right, so what if it's unbounded on both sides?
It's just
like
two arrows.
How would I notate that?
Negative infinity, positive infinity.
Negative infinity to positive infinity. Or, what's all reals. So I can use that funky looking R. I can go R, all reals. And you can notate that either way. And that would be unbounded. That means it's every possible number on the number line. Okay. That's kind of the theory. We're good with that? Any questions? Because we're going to do some practice with that. Solving some equations and graphing. Okay. We good so far? Is all this review? No? You haven't seen some of this? Awesome. First day, new stuff. Love. All right. Let's do some homework problems. This is going to be something you might see in homework. Something like, it'll say graph or put interval notation, x is greater than 4. Rewrite that in interval notation or maybe graph it. Okay. So x is greater than 4. So the first question is this an open or a closed interval or half open, half closed? How do you know it's open? Because it's just greater than, right? The line underneath it would tell you it's close. So this is an open interval, okay? So if I were to look at a graph, I would say, okay, I would start here at 4, and it's open, and then x is greater than 4, so it's to the right. So what would that look like in interval notation? How far to the left does it come? Left.
Oh,
Comes over to 4. To the left, the farthest it comes is 4.
Okay, my bad.
And we know that that's open, so that's parentheses. Now give me your answer, Emma. Now it goes to the right forever, so now it's going to be unbounded infinity. I don't know about you, but sometimes it helps me to just catch a quick little graph of it. And notice when I do a number line, I'm not doing 0, 1, 2, 3, 4. I'm just putting the number I want in the middle.
The numbers kind of don't matter when it comes to infinity.
Honestly, no, they don't. As long as you're going the correct direction. All right, let's do another one from homework. This is going to be a good one. We have another example. -1. Less than x, less than or equal to 3. X is less than, -1 is less than x, which happens to be less than or equal to 3. So let's just think about for a second, what are some possible solutions here? Could 0 be a solution?
Wait, is x?
Yeah.
X has to be greater than -1, so 0 is greater than -1.
Yeah.
0 is less than 3, 0 is a solution. How about 3?
Yeah.
Yes. Yeah.
Because it could be equal to 3. Perfectly fine. How about negative 1?
No.
Why?
Because it's not open.
Because it's open. Very good. So if I think about this in the number line, I think about here's negative 1, here's 3. I know on 3 I'm going to go closed. I know on negative 1 it's going to go open. Going back to it's equal to, it's not equal to. And then it's every number in between those two. So this is going to be a half open, half closed interval. So on my interval, I'm just going to put the numbers, I'm just going to bring them down. Negative 1, 3, and then you just have to check are they parentheses or brackets. Yeah, parentheses on the left-hand side because it doesn't get to negative 1, but it gets to 3, so a bracket on the other. So open, close, and then your answer. All right. Here's one for you to try. You try this one. Give that one a try. You don't necessarily have to do the graph, but give me the interval notation. If the graph helps you, use it. Sydney, am I going to put closed dots or open dots? Why? Because it's including the equal to, right? Okay. It's a closed interval. The equal to signs are there, so closed dot. And x has to be greater than negative 4, but it has to be less than 5. Okay? So, what's my interval notation? Yeah.
Parentheses negative 4. Or not parentheses, bracket 4, negative 4 and 5 bracket.
Okay. Brackets around negative 4 and 5. Great. Negative 4, 5, brackets. Okay. All right. I'm kind of done with interval notation. Is there anything we need to go back over? Any kind of practice we need to go over? Okay. We're all at least a 3. Fantastic. So we're going to switch topics just a little bit. Okay. Let me see here. We're going to go to distance. So I guess this would be like Roman numeral 2. And normally we don't jump this many topics, but here at the beginning, we try to get through a lot. Okay, now we're not talking about distance on a coordinate graph. We're just talking about the distance between 2 points. Okay. So it'll be notated either dist or it'll just be d. One of those two. And we're just looking between 2 points. P and Q just stands for two real numbers. So the distance between 2 points. So give me 2 points. 5 and what? 5 and 10. Okay. I was hoping you weren't going to say 5 and 6, because that would be really good. Let's go the distance between 5 and 10. Now everyone should know the distance between 5 and 10. Okay. Distance between 5 and 10, right? What is the distance between 5 and 10? 5. Not 2. Now how did you get this? How did you get 5? Does it really matter which one you subtract from which? Okay. So distance is actually defined as the absolute value of P minus Q, which is equal to the absolute value of Q minus P. So as long as you just subtract them, it doesn't matter which one comes first, just always take the positive. Distance is always a positive value. Okay? Real quick story, years ago, my son, who's now 19, living in Illinois, was like 5 years old at the time, maybe 4. And my wife, his mom, said, hey, we're going to the doctor, go get in the car, we're ready to go. He just, okay, jumped up, went to the car. They got down the road, they were driving about 2 miles down the road. She turned around and looked, no shoes on. He's going to Children's Mercy Hospital, he has no shoes on. How's he going to walk in there, no shoes, no service, that thing? She's like, I cannot believe you forgot. So she had to turn around and go back home and said, go inside and get your freaking shoes on. Okay? How far did they travel?
Well, she got halfway there, right?
2 miles.
2 miles, so it was about 4 miles.
Travels 4 miles, right? But they're right back where they began. So displacement, they haven't really gone anywhere, but they have gone 2 miles both ways. So when we look at distance, it's simply the absolute value of wherever you are to wherever you went. It doesn't matter if you go for, what was that one show? You guys seen Ferris Bueller's Day Off?
Yeah.
Yeah? Okay, what did they do at the end to try and roll back the odometer? Remember that?
Didn't they go back?
Yeah, they stuck it in reverse. They put up on ramps and stuck it in reverse, thinking the odometer would run backwards. Okay, it doesn't matter if you're going forward or backwards in a car, you're still traveling distance. Okay, so distance is just the absolute value. So it doesn't matter if I do 5 minus 10 or 10 minus 5. Either way, the distance is going to be 5. It's just the positive value of it, the absolute value.
Oh.
Okay. Now that's not that big a deal until we start getting into some decimals and fractions and some integers. Okay. So let's look at that. Let's go find the distance between negative 1.3 and 7.2. Find the distance between negative 1.3 and 7.2. Now all of a sudden I got a little bit maybe more complicated problem.
Was it 8.5?
How did you get that?
Just added 1.3 to 7.2.
So you did 7.2 minus negative 1.3, and 2 negatives make a positive. So 7.2 plus 1.3 equals 8.5. Or you could have done negative 1.3 minus 7.2. Those would be equal.
So you're just getting the negative to 0 and then adding all that.
That's another way to do it.
Yeah.
Take 7.2 to 0 and then just add, either way. That's actually what adding a negative is from integers. Yep. So you just subtract the 2, doesn't matter which way, you just always take the positive. Okay. All right. Last one. I'm running out of time, so last topic, Roman numeral 3. Prime numbers. What's a prime number?
A number that
Can be
can't
5
multiplied.
multiplied with
Say it again.
5.
That is an example of prime.
Is
Who needs the definition?
whoops.
What's the definition?
A number that
Do you
can't be
remember that can't
multiplied.
be multiplied?
What'd you say?
Number that can't be multiplied. Like
I see what you're saying, not quite right though.
Nothing, it can't be like, 2 things can't be multiplied together.
Yes.
Isn't that like, it's just kind of the idea of it can't be divided without ending up in decimals?
Kevin?
Isn't prime numbers just like a number with only 2 factors?
That's exactly what it is. It has
good job, Kevin.
exactly 2 factors. So I kind of see what you were saying. 2 things can't be multiplied to equal it other than
Yeah, that's
one in
what-
itself. Other than one in itself. So like 3, the only way to multiply to equal 3 is 3 times 1. It's the only 2 factors. 3 is prime. Okay. 2 is the only even number that's prime. 2 times 1. There's no other way to get 2 except for 2 and 1. Every other even number, 2 will go into it. So 2 is the only even prime number. Yes?
Is 1 prime or something?
Great question. What multiplies to equal 1? And we're talking about natural numbers, and we're not talking about integers.
1.
One number, 1 times 1. So is that exactly 2?
No.
No.
So it's just.
Interesting enough, Kevin, this is a deeper subject, but 1 is not composite either.
Huh?
It's either prime or composite. 1's not composite. So 1's kind of a weird number, kind of off by itself.
So it's like the 2, 3, 5, 7.
Yes, so the answers are 2, 3, 5, 7, 11, 13, 17, 19, and so forth. 25 prime numbers between 1 and 100. Okay. Now, we take that, you did that when you were in elementary, I can't remember what grade, to do prime factors. I always learned the factoring tree. Do you guys remember that?
Kinda.
Factoring
Yeah.
ladder, maybe? Give me some.
No, we never had any of that.
You never had the factoring tree or the factoring
Oh, is
ladder?
it-
I
that
had
could
the
look like
factoring.
this?
That could have just been my
What'd you say?
elementary school.
Like it goes like this.
Yes.
Maybe.
So you had the factoring tree?
I have.
At least you remember it by that name?
Mhm.
Okay. So every number out there, every composite number can be written as a product of primes. So let's say I have the number 36. 36 is obviously not a prime number, but I can write it as a product of primes. Okay? So any two numbers that go into 36.
Yeah.
This is the factoring tree. This is the factor. You didn't call it the factoring tree. What do
It
you
was
call
just
I don't
doing
know
the
what
math.
It was just like, this is how you do it.
Exactly,
Yeah.
yeah.
It's called it's called, because there's a ladder, you can do it by a ladder too.
They were just like, just do, you just do
Yeah,
this,
yeah.
and you just keep
It was- they
going.
were calling
We
it
actually
something.
made trees and colored them and everything.
No.
See, I
Oh,
would have done
that's
so much
cute.
better than
Yeah,
you.
yeah. We
All right,
did that.
so how do we do a factoring tree then?
You just find what numbers that multiply into that, and you keep
Find
going,
its
and keep
factor.
going.
Any numbers that go into 36, except for one in itself.
6
So
and
is it
6.
adding
6 and 6, I could
opposed to
do
multiplying?
3 and 12,
Is it adding
3 to 12, I could also do
2 and
4 and 9.
4 and 9, or 2 and
18.
8. I do any of them I want. You always get down to the same, that was the thing, you're always gonna get to the same roots.
Okay.
Okay, so let's use 4 and 9, because that's the first one I came up with, first one I was thinking. So we know 4 is 2 times 2, and those are prime numbers. We know 9 is 3 and 3, and those are prime numbers. So I know I have 2 times 2 times 3 times 3. Or if you really want to be good about it, you could write 2 squared times 3 squared. Okay? Or if you really want to cheat, you can go to the calculator and hit, anyway, we won't talk about that. The wonderful TI Inspires does that for you. So, product of primes. Okay, so it doesn't matter if you start with 6 and 6, you got 2 times 3 and 2 times 3, you get the same answer. Okay. Give me a number on that. Do we need to go over more examples, or I did not want to waste your time if you know what you're doing. Okay, I got a 3. Okay. All right. All right. All right, very good. No 5s. No one ever puts up 5. Like, yeah, I'm ready to teach somebody else.
No.
I didn't realize we were doing that retrospective.
You're what?
I'll put up.
I put up 5. Very good. You can teach somebody else. Okay. Well, that is it for lecture 1. Where I'm done. Okay. You got about 5 minutes left to go in class. Delta Math has been assigned 1A and 1B. They're not due for a few days, so I'll give you some time next week to work on them as well. Trust you have a great Thursday. I will not see you now until Monday. So I'll see you Monday. Hey, if you have any questions over the notes or the math or whatever, you can always send me an email. I do try to answer email the same day. If you email me at night, it'll be the next morning. Always connect through email. It's a great way. I know kids hate that, but that's the way I...
It's just like the version of texting.
Very similar thing.
Good morning, Barbara.
Just not the bell. Hang on.
All students, please come down to the
So we started on
student.
the
Jade Gray, Wilson Brown, Denaya Chandler, Kamaya Doyle, Fumi Keo, Detanta Bomick, Mackenzie Miles, Delina Connor. Please come down to see Mr. Mendez. and-
Sorry.
So it's like a really
Yeah. I gotta do that same thing. No, it's, but thank you for that. You're welcome to come back and teach it. Where were you at last year again? Oh, like the west? West. Most people live south and north. What branch is your?
Oh, I just
Well, welcome to school. Are you a junior? You're a senior? And you're doing dual credit, that's why you're doing I'm not questioning that.
algebra 2.
I have seen no transformation, so I have no idea. That's why
I didn't do it last year. First semester, I got A both
semesters.
Have you thought about switching to 120? What do you?
What's 120?
It's a pre-cal. It's college algebra plus trigonometry.
No.
This is pre-cal too. It's just the college algebra.
Yeah. I'm better at algebra.
So what are you going to? Have you got a college? What are you going to college?
Either business management or like education.
You know, neither one of those would be pre-cal. The business management, maybe would take a business cal, but they wouldn't probably accept your best. Cool. Do you play any sports?
No, I mean, there's been teachers trying to get me to, but I don't.
You don't like sports, you can always do theater.
Oh, yeah, I don't really like theater that much.
That, you know, that's
I got one more shot of this. Have you ever heard of Scalable?
not.
You know what's coming.
We're all doing the pitches.
No.
Do you know what Scalable is?
No.
So it's like, it's an academic team, and we go to tournaments, and basically you're asked questions, and you go through and try to answer for.
Yeah.
It's
I
like
would-
advanced
I feel
trivia.
like I would not be good at that.
Well, you have to be really smart with rules, I think. So, and it takes a while to get through the questions, so.
You have to know a lot of random facts.
Are you guys gonna be good this year, Mr. Phillips?
We're the defending conference champions, we hope to
Chill.
defend.
Wow.
We chill.
We hope to defend. So, we'll see.
Done fantasy football yet?
Our draft is Sunday, actually.
Sunday.
We decided to do it right after the last Chiefs game.
Alright.
So we're doing something. So last year, I lost the championship game.
Oh, to who? I lost my championship game. To him.
Yeah, you don't know this good for church.
Oh.
So, I lost the championship, so now I'm picking 11.
Oh.
So 11th and then, what, 14th? So,
Oh
because
yeah.
the snake-
Oh yeah, because the snake was right. That's not bad.
So, you know, I was thinking about that too. If you're picking first, you get the best player,
And then you get like
and
2.
then you get 24. You know, so if you're picking like 11, 12, 13, you're getting, I'll get 2 of the top 14 players.
That's good.
You know, that's not bad.
I think the worst one's like 7 or like
Oh, yeah.
6.
Dead center.
Cause you get like a good player, and then you don't get anyone for a while, and then you get like someone in almost the 20s, then you get someone in like the 30s.
Being in the middle of the draft.
Yeah.
Oh, yeah, because you walk in.
Because at least like number 1, you have that one crazy player.
Yeah.
But
Yeah.
I don't know, we need to set apart.
Well, who's the craziest player going to be besides Patrick Mahomes? I mean, ours is quarterback heavy.
Oh, well then Patrick Mahomes. But for us, it's, I don't know, it's more spread out and even. Like quarterbacks, like on a good day, will score like 25, 30. So the best player is Christian McCaffrey because catching and running.
So who's your sleeper? Give me one sleeper that I can
Ooh.
See you later.
Oh, the guy for the Saints, the quarterback, tight end, running. What's his name? I just forgot his
I
name.
know you're talking.
Because you can start him at tight end or
But he gets
receiver, but he can get. I don't know. Me and you both know. I forgot his name.
Yeah, it's just, it'll come to me.
Yeah, I'm trying to get him.
Well, good luck in your draft. When do you guys draft?
We have.
Hey, how are you? Sakairo, right? I got it. Look at that. How awesome. The money's right here.
My favorite class. I love the $12. Anyways. Circles. Oh, I don't like that word. Let's take those and math off of it. Not necessary.
No, I think you should be in that. I just got back from just a little bit.
What's that?
It's just a study hall.
I literally did nothing for like the entire
In the library.
He's not. Oh, I just stole this.
I haven't started at all. I'm just like scavenger hunt everything through things.
Wait, what's that? In here?
Yeah.
Oh. No, no, why? Oopsie. What? She gotta be hella smart. Ain't this a college course? Oh, you big smart, Marco. Period. I missed you. Did she really say this in your scholarship?
Yeah, she said, ask her to she said
Adults?
it's
What the fuck did she do? My mom probably taking it. What? Oh well. We'll see how that goes. Kimberly is even sick, like more sick today, bro. I don't know if she's gonna make it. What?
Oh, I don't want it.
And she was coughing all last hour.
Did she tell you that someone was on her car?
Someone saw her cry?
Someone tried to steal her car.
Oh yeah, she did.
Yes, ma'am.
How's it going?
Don't tell me that now I know you have it. Now I know I didn't see it, so I'll just pretend I didn't hear it. Oh, yeah. How are you doing?
I didn't know we were supposed to do this.
That's the one. Okay. Hi, how are you?
1, 2, 3, 4. 7. This is 7. Okay, good morning. How's everyone doing? Real great.
Yes.
This is 5th hour, and I should have 1, 2, 3. Beautiful. Volleyball is selling shirts?
Yeah. They usually are. You gonna buy one?
Should I buy football or volleyball?
Volleyball.
That was pretty quick. What if I don't want a volleyball shirt?
I mean, it's your money.
Yeah, I already have a football shirt. So I could buy a volleyball shirt. I've never purchased a volleyball shirt.
Yeah.
Do you guys get some of the money?
Like the players?
No, does the team get some of the money? I don't think players
I don't
do.
know. Probably goes to Anchor.
Cause you know, if I'm gonna spend $20 on a shirt and you're only gonna get like $1, I just get the $20 in the volleyball store.
You can ask.
But if you're gonna get like 10, I get half of it, well, shoot, then I'll get it. Scholar Bowl is kind of the way it happened last year. We sold them, then we lost so much because the profit was gone, so. All right, so good morning. We're gonna give you 35 minutes. We need you to do these things. Some of you have done the syllabus scavenger hunt, some of you have not. Get that done so we know what's in the syllabus. Dual credit, how many of you have started the dual credit application?
No.
Okay, if you're going to do the dual credit application, you're gonna have to get started today, but it is gonna send an email to your personal email. So you can get started, and then when you get home, do that email and get that sent to your parents and so, but get that started today. And then there is an assignment on Delta Math. If you haven't logged into Delta Math, 1A is ready to go. We're gonna give you 35 minutes and then we're gonna finish lecture 1 today, 1B. Question? No question. Okay. Question, yes?
I think I accidentally logged into the wrong Delta Math class.
I can switch your classes,
Okay.
because I'm sure many people have done the wrong numbers, because they were wrong to begin with, they had the wrong numbers on them, so.
Yeah.
Yeah, I think I need to add a class, cause I have like the other 2 classes of math that I did, but it's not.
So do you know how to join a class? Click
Well,
on
it says
tool.
add new class.
So I click add new class, and then the code is on Schoology. If you look under Schoology and there's a Delta Math, there's a code in there, I don't know what it is. But you can't copy and paste it. You have to type it in yourself. Because if you copy and paste it, add something, and then it doesn't work. So you have to type it in yourself. Okay? Questions?
Well, it was just like disappearing every time I would try to add a new class.
Is it always this one? There's gotta be something. Well, you know, I'm having issues with mine too.
I haven't been able to do anything this whole week.
Hey, what?
I haven't been able to do anything computer-wise this whole week.
Well, I was going to find this morning, but now it's not letting me do anything.
I can't even load up on that computer, especially this computer too. This is ridiculous.
Yeah, see, mine's free. So what's this is 50. That's what's good. So now it says class added successfully. But it's still loading. And you're showing up on my roster. check the due dates. Like one's not due till next Friday, one's gonna due till Tuesday or Wednesday after that.
Is the syllabus scavenger hunt gonna be on your part of the syllabus or all of it?
I can't be questions. Mark, I got you switched to fifth hour clock. She didn't know when you were on. I mixed up the numbers, so I got you.
Okay.
You probably won't even know, but you're good. Nice long evening. You help me, please. I'm not going to try and keep you, I'm saying.
From my youth. I don't have
So you think that's cool? Was that earning opportunity? What was your experience?
No, I think it's like it.
I'd rather do the same for you. Okay. All right, have you read the council now?
Yeah, I'm just waiting my turn to go and then
Call names? Okay. All right, very good. Well, I think we're sure. Because some kids said they're going to drop and they decided not to, and it's far behind, so. All right, very cool. Okay, about 20 minutes. If you need any help doing anything, please let me know. Hey,
Do I do the email like for school or my phone? So it gets into my phone or my computer? Because I have two different emails. Like one for school.
I use my personal, but I can still get to my computer.
Okay.
Is it a Gmail or just
Yeah.
the Gmail? So if you just open up Edge and go to google.com on Edge, that's how I do it.
Okay.
Let's see if that works. If it doesn't work, I guess you can get your phone to check your email.
Okay.
You may have to do a whole application over there. So you don't actually have a textbook, but it's tied to Blitzer. Blitzer is it. This class doesn't actually use a textbook,
I was gonna say, I'm like,
but UKC requires you to tie it to one. So, Blitzer. 7 minutes when we start.